practice this. So, okay, hi, I'm Bryan. As he said, I am co-founder and also CTO at Spotahome now. I don't know if you already know what Spotahome is. How many of you already heard about this company?
Using it.
You are?
Yeah. Living in one of your
Amazing, man. Soon everywhere there will be spotters, So, yeah, we are part of the product team, okay? I'm in the role of CTO. Basically, I'm, like the voice of the technology in my company, okay? They are leading the front-end team, okay? And split into parts. One more focused in the JavaScript architecture, and the other one focused more in the CSS architecture and user interface development, okay? And, well, they are the team right now with one more person that is not here today. And this team will grow a lot, okay, in the next months. So we have to face a lot of different issues and problems how to make a team grow. And actually, we are in this moment of the company. We started 2 years ago. We've been from 4 founders 2 years ago to now 125 people. So it's kind of challenging to find the right way to scale a company that way. Things go very fast, communication problems, everything, and we are trying to face that stuff. It's really exciting at this moment. Here is Daniel Molina. He comes from Open Nebula. He's a very experienced front-end engineer and very focused into JavaScript architecture. He's very talented, and he came and basically revolutionized the whole way we were doing JavaScript until 1 month, 2 months ago. And then there's David Rodriguez. He comes from Thank You. It's a startup about weddings and how to, well, I don't know how to explain it actually, but it's a very cool startup, and he was just developing all the user interface and front end there, okay? And we are going to do this talk in 3 parts. We're going to talk about how to do, how we started, how we get to continuous integration and delivery, and how we introduce the front end testing, and what is coming next in terms of front end testing as well, okay? And we'll do this from a practical point of view, so you will see more or less how we're dealing with this every day, okay? So, basically in the beginning, when we started, this is Hugo and me. Hugo is my colleague, also co-founder of Spotahome and also technical. He is more in a role now of VP of engineering. He works remotely from Lisbon, so he's not here as often as I would like to have him here. But he helps a lot. He is very, very strong skills engineering, and he's more focused into the architecture of the whole platform right now. He's trying he's in the moment that he stops developing a little bit to be more focused in a long-term strategy to develop the product. As you see, 2 years ago, we were very young. We were very, at least me, because you can compare now. I was thinner, I was happier, nice too. But it was this was like the first or second day we started coding. We were I was living in a hostel there because I didn't have a house when I was there. And basically we were just starting to do things in the living room of the hostel. And what happened? Well, we were 2. Nothing was done. We have an idea. We have no code, no platform. There is nothing there. So it's full of space to start developing, to start doing whatever you want. Of course, you need to be focused in the goal you have. Always, never lose that. Okay, but we could do everything. There was no collision with developers. There was no collision with the legacy code. There was no collision with functionalities. There was no collision with features that needed to be working at the time while we were developing. Okay, and we had a full view of the whole thing, the whole business, the whole platform, all knowledge. It was very easy. It's because there was nothing. Okay, and it was like so for more or less 1.5 years. We did code review. We had pull requests. We had a complete Git workflow. We didn't start just coding per se. We had some kind of workflow, but it was not efficient. But for us, for the 2 of us, it was more or less okay. We didn't have any kind of testing. We were writing code very, very, very fast. We were doing hundreds of lines of code every day, each of us. And well, the workflow was basically just keep coding, shipping, always fail, break things fast, fix them faster. If not, you're fucked, okay? You need to go very fast when you're developing a startup because every single minute counts. And we had everything in one single machine. There we had the blog, the application, the databases, some batch processing, everything that we were doing. Batch processing in the beginning, for example, I talked about the photo resizers. When we started, the first thing we developed was the photo resizer and the listing editor. The photo resizer was basically because we were uploading photos of a few megabytes. You can present that to the user, so you need to prepare maybe 10 different sizes. This is the typical tool that every startup needs when you make a marketplace. And the listing editor was because we needed listings. We needed the actual pages of the properties we were selling in the platform. Okay, so we needed this be done first, and then in parallel we were doing the first version of the website, which was very basic. Well, in the first year, the business goes to work and starts growing very fast, and it starts to rush us to develop more features and more features. It's not easy because we are two. One of them is in Lisbon, as I said, so I was basically facing all the issues, all the problems, all the tech part. And around me, I had maybe 30 people asking me for things. It's very difficult to handle all that. Okay, so I was doing a role also like a product owner, more or less, because we didn't have anybody else to do that. Okay, the code base grew a lot. We started doing unit tests, but we were not very experienced into that. We're not very professional, so there was no strategy. And we started to create some deployment scripts. They were run by hand by me in the machines directly in Amazon, but at least they were a set of scripts that worked together properly, and you could deploy safely without all the idiosyncrasies of deploying a new version of your platform with the downtimes and so on. There was no downtime at all. Okay, and well, this is one of the examples of the old scripts we have. Okay, it's very shitty. Then what happened? Well, everything grew, so the new workflow we had was slow feature delivery. Basically, pull requests started to get very big, code review was very heavy, and releases were very heavy, very big, and slow to deliver. So this created also some friction with the business. We need to find a solution, and it was the first time that we actually thought that we desperately needed to make an investment in technology. At the moment, we were very young, although the business worked, we were not very funded. So we didn't have enough resources to actually hire more people. But then we decided to do this, and well, we thought that this was a problem, so we decided to invest. And the first commanders that arrived, the first one was Michael. Michael was already here in another talk. He was the first engineer that joined us at the beginning, 1 year and 3 months ago. And also, when we were three, the processes we had were not enough. More or less work the same. I mean, you know what you have to do, you have a list of issues, you just take it, you just apply your knowledge, you try to fix it, you try to deploy it, and more or less it was working, but it was not clear, there was no predictability on when the features will be delivered, and so on. The code grew a lot more, but the quality started to decrease very fast, so bugs start to appear, and it's not a good practice. So the backlog started to grow a lot. Then later, Charlie, who came from another company, very experienced developer, and was arrived. And one helped us to improve our Git workflow, which was kind of good, but had some problems. And also helped us to make a bet for continuous integration and delivery. Who of you here is already know already the concept of continuous integration and continuous delivery? Are you familiar with the terms? Yeah. Okay. More or less. Okay. I will explain now. Okay. So. Well, first of all, the Git workflow, the way we work is more or less like in free software. We have a main upstream repository where everything, I mean, this is like our original, okay? Then we have what we call the origin. Every developer makes a fork of the upstream to their own GitHub accounts, let's say. And from that fork, they have to, well, from that fork, they create a copy in local. And what you do is that you track your branches. For example, master branch, you track your local master branch with the upstream master branch. So you're always updated when you do git pull. And what you do is that you push your changes to your origin, and then you do your pull requests against your upstream. So by doing this, it's impossible that the user will actually make accidental pushes to upstream, and you can have more control. It works very well with very large organizations. So for us, being a very small organization made kind of no sense. But we wanted to be ready for scaling, okay? So we altered this, and we still use it. More or less, it works quite well for us. What happened in that moment? Well, we have branches for master, branches for development, branches for releases, and branches for features. Indeed, it was very difficult. And being only 2 or 3, it was useful to have this kind of mess constantly. And it was unmaintainable, it was very difficult, and you don't want to be in this kind of metro station map. It's really horrible. It really improved a lot. So basically, we started with continuous integration. What we wanted is to start a new, let's say, strategy or mindset in the way we work with the code. So we decided to take out all of the branches that we didn't need. So we just kept the master branch. And with the master branch, every engineer will have a fresh copy of master and will create their feature or their epic branches directly from that one. Okay, so everything is updated with master branch. There is no level anymore, there is no feature anymore, there is no release anymore. And the idea is that you have to strategically think in the way you make the issues, you resolve your issues, so you can ship code every day or almost every day, and this code is able to go to master directly without damaging the platform, okay? So you have to do very small pull requests, you have to also think a little bit in advance, because maybe you will deploy later that code to production, but you don't want your feature to be seen in production by the users. How do you do this? You do it with the feature toggles, for example. With feature toggles, for example, imagine that we want to translate the platform as we are doing currently now. We are translating everything. We have more than 18,000 pages translated right now to Spanish. We are only working in English so far, but the user is not seeing this. So how do we do it? Well, everything is working behind, but until we have the front end ready, the front end has a feature toggle that avoids the user from seeing that option, for example. There are many ways of applying this kind of technique, okay? And also we introduced a pre-production environment, which allowed us to test in a staging environment, but in a more close, more like in a production way, because it shares some part of the configuration. What happened is that the efficiency of the team increased a lot. It was kind of amazing, but it was not enough. We also wanted to apply continuous delivery, and continuous delivery means that anything that you have in master is safely deployable to production. So, or at least you know that it's safely deployable to production. So, right now, for every commit in a pull request that an engineer does, automatically we build an artifact and we pass the unit tests. And if it doesn't pass the unit tests, we cannot merge it into the master, okay? And then for every merged pull request, we do the same. We build an artifact, we pass the unit tests of the whole platform, and if it passes, it will automatically deploy to the staging environment. So we always have a fresh copy in staging of what's in the master in the latest version. Okay? And if we want to ship to production, we just have one click button, we press it and it deploys. Basically, we are ready to deploy at any moment. Okay? And if something fails, we can always roll back. Okay? So with this, of course, efficiency increased a lot more. So how does this work? Well, we have the commits here, we have our version control systems, and then we command with some tools the build phase, the test phase, the staging, deployment to staging, and the deployment to production. Okay? And there we have a repository of artifacts where we have all the builds. So if we want to roll back or do something like that, we always have here this historical. And in the practice, we use Snap CI for doing this. And this is more or less this is the panel we use every day, okay? Here you can see, for example, this is today or yesterday. We have a failed deployment to staging. And then, if you can see here, there is a hotfix to fix actually some smoke tests that were failing. And suddenly it was okay in staging. So we could have deployed here in production. Okay, but we didn't need it, so we just kept. Until this morning that we deployed twice. And it was actually the time that it was deploying. Okay, and how does this look internally? Well, each of those phases, you have the build phase with data sets and deploy staging. I didn't talk about this phase before because this one is special for the frontend assets because it takes a lot of time to build all the minification of the JavaScript files and so on. It takes a lot of time, so we prefer to abstract this part from the unit testing to make it faster. So, for example, in the section of deploy to staging, this is what it looks like. We are just running some scripts, and this is controlling some environment variables and making Snap CI system know that it's safe to deploy now to production. For example, another phase is the build phase. Well, we have everything covered under a script, so you cannot see the details, but there are some lines of code that call other scripts and basically command the deployment to the machine. So what happens? It's very common to make this mistake to confuse the terms continuous integration and continuous delivery. Continuous integration just aims for having every engineer synchronized with the master branch and making them able to work very fast, shipping code to the master branch always in the most updated version. So you never have, as I say here, integration issues, okay, to ship your code. You are never stuck because something is broken in the master branch and things like that. And continuous delivery is basically making your code be safe to deploy at any moment you want. I mean, you are in control on when you can deploy. So at some point, you can introduce another concept that is not here, but we use in staging, which is the continuous deployment. What we do in staging is that if everything goes well, we deploy automatically. We don't do it in production because we want to keep that at least to be controlled, okay? But it's different. I mean, these terms are different, and it's very common to see that people confuse them. And what happens today? Well, we are many engineers. We are 13 today, and we have many repositories. We are splitting now the monolith into different products. This will take a few months. Also, we are starting to create reusable libraries from components that are common to those products. We are taking them out to be their own repositories with their own installable packages. In our case, we use PHP, so it's through Composer. We also use, for example, for JavaScript, we're going to use NPM directly. Also, we are applying domain-driven design and microservices strategies to divide the platform into different microservices. And well, the idea is that every product that we develop and every library will have its own repository with their own continuous integration and continuous delivery pipeline, which is most important. And also, we recently introduced smoke testing, okay, and integration tests to try to go further. In the unit testing, for example, we are only focused now in the business logic and the most internal parts of the code and the application logic of our platform. But now we're introducing also integration tests to join many parts, and also smoke testing to test more from a user perspective, okay? And right now in this aspect, we're also looking for, we're hiring and we're also looking among all the roles for some QA and software engineering tests to help us command this and define the strategies we're going to follow in the next years. And now the last thing we did is to integrate this with front-end testing, which we didn't have before, and Danny will come and talk about that.
Okay, so hello everybody, I'm Daniel, and as they said, I'm working in the JavaScript part of the Spotahome solution. So first of all, how many of you are familiar with JavaScript? And how many of you doesn't know anything about JavaScript? Okay, perfect. So first I'm going to start talking about how does it look like the stack of the front-end part, and what are the actions that we are doing to improve the code quality and the testing of this part. So first of all, we are using Webpack. So Webpack is a tool to manage modules in JavaScript. The thing in JavaScript is that there are no modules. There are no a thing like require this library and use it in several places. You need some tool to do that thing. So Webpack is one of the most common used, and it's also used to build the assets of the application. In a JavaScript application, you probably have 200 files or something like that, and since it's running in the browser, you need to retrieve as few files as you can. So what you do is merge all the files in 1, 2, 10 files and retrieve them. So Webpack is the one taking care of that, merging the files, minifying, and sending it to the browser. And then instead of using vanilla JavaScript, plain JavaScript, we are using two frameworks that are React and Angular. Angular is used in the internal tools of the company, and the website that you can access publicly is using React. Both are really good tools. React, I'm kind of in love with it. It's really, really good. So what's the first step that we took to improve the code quality and being able to scale the front-end team in the future easily? So the first thing is defining coding style guides. For that, you use linters. Linters are tools that tell you what you are doing wrong, and they force you to fix them. We are using ESLint because you can define custom rules, adapt it easily, It supports GSX, that is a thing that React used to inject HTML inside JavaScript. So that was the best option for our interest. We are using it currently in the IDE, and we're also using it in the build process. When Webpack merges all the files, it checks that the rules that we have defined are met. You can also force it in Git hooks. When you want to push something to the Git repository, you can force it. There is a rule that is not met, do not do the push to the repository. The other thing that we included is rollback. Rollback is a service to track errors in coding, in any language, in anything. Just push the error and you get notified of the error. So we included the front-end error. So now every time that there is an error in the web, we get notified and the alarm starts to stand. The next thing is code review. As Bryan said, every time that there is a pull request, if you want to merge it into the main repository, you have to have the thumbs up of someone. So someone has to check everything and say, okay, this is, it passes. And the last thing is testing. So testing in the front end is something really difficult. It's something that usually there are no tests for front end. It's just going to the website and checking that everything works. But what's the problem with the front end testing? The thing is that if you are testing Ruby, you are testing Python or whatever, you just have code on a library. You write a test and use the library to test the results. The thing is, in the front end, you have another layer that is the browser. You're not running the code yourself in a machine. You're running it in a browser. So you need the code, the test, the browser, prepare a page that load the JavaScript and run the test in that browser. So it's really difficult. So this is the tools that we are using for front end. We have evaluated several options, and probably there are better solutions or other solutions. But this happens a lot in the JavaScript world. There are a lot of options and a lot of good options. So you just have to choose one, and if it fits your requirements, it's okay. So the first part that we are using is Karma, that is the test runner. It's the tool that is taking the test that you wrote, your code, your libraries, and putting it all together and running a browser with all those files. Mocha is the, I don't know how to say it in English, is the test framework. And the test framework is the one that is providing the API to write the test. It's the one that says, okay, I'm going to test this component, it should return this, blah, 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 and define before hooks and all these things. We're going to show an example later. Chai is a session library, is the one that allows you to define, run this command, and it should return this thing. So it's like the assert library.
What about live things? Check.
Okay, perfect. You're right. Okay, Xenon is the mock spy stuff library. I think some of you have done some testing in Ruby with Sinatra. In Sinatra, sometimes when you are doing tests against a server, you run a mock server because you don't want to start the server and use real request. You are faking it and putting something that looks like a server, but is something that is not real. So in JavaScript, you have to use it a lot. Also, the spy functionality is like putting a man in the middle in some methods, because you want to check that a method was called with a set of arguments, but you don't know exactly what is that method. So you put a spider, and you can check that to see if it's correct. And the last one is Consign, that is a helper for React, but I will not go in detail in that. So this is an example of a test in JavaScript. As we said, the first component is Karma, the test runner, and we just run the command that is npm run test. This will call karma, and we'll start our test. Karma Karma will allow us to run the test in several platforms. We can say, okay, take this test that I defined, run them in Chrome, in Firefox, in Chrome for mobile, and all those kind of things. And it also allows us to run the test in an environment without a real browser. They are called like headless browsers, that are browsers that can run in a server. You don't need the application itself. We are using Phantom.js, that is one of the most common headless browsers. So now with live, I think you cannot see anything. But this is an example of the test. Mocha, the test framework, is the one that allows us to describe it should blah, 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 blah. Then we have the assert library inside that I said before. That is one that let us to say expect this method to have length this one. You can define all the tests like that. And then the spy functionality. I think the presentation will be available online, so you can check in detail the functionality of each one. This is already running. The framework is included in the code, in the repository. And it has been also included in the continuous integration delivery, the NavCI pipeline. So every time that pull request is merged in the main repository, all the JavaScript tests are run. And if it fails, there will be an alert. So this is not finished. There is a lot of work to do. So in the short term, one of the actions that we are going to take is moving to the new JavaScript standard. I don't know if you have heard about it. It's called ECMAScript 6 or 2015. And it's really nice. We are already writing all the tests in this standard. It includes some functionality that makes JavaScript kind of a real language, not a plain. It's really nice. We could have another talk about this. The next step is the extract components in NPM modules. What this means? The libraries in JavaScript are managed by NPM or Bower also. It's like the gems in Ruby. You have a gem, you gem install Sinatra. And so we are taking part of our code, creating a module so we can use it in different projects. And even in the future, we will make some of them open source so the community can use them. The next part is the backend for frontend. This is a really interesting concept. That is putting a component between the backend and the JavaScript. So the front-end developers can do things for the JavaScript code without modifying the code in the backend. This concept is using a lot of applications in SoundCloud, in Spotify. They have several backend for frontend, for mobile phone, for the desktop. So you can really improve what the backends provide you to put it in an application or in a desktop. And in the long term, we want to do full navigation test. What I've shown now is like testing of libraries and functionality that is really encapsulated. But sometimes what you want to test is the whole user workflow in the web page. So you want to connect to Spotahome and check that someone that clicks the button will receive a form with to fill. Okay, and the next steps are visual regression tests that David is going to talk a little bit about it. So I'm finished with part.
Hi. I'm David from Spotahome. I'm front-end engineer. We actually 2 months old in the company, so we do things, but not too much. Right? And I'm going to talk about user interface testing. How many of you use CSS for everyday work or play? So you will see, it's the quickest one. So because in CSS you don't have so many tools to do this. The only thing you can do is for testing is regression testing. That only checks that you don't break things along the way. And there are not so many tools, but the most popular one is Break. That is one from the BBC front-end team. And there are some more, but usually it's the same thing all the way. How it works? It only takes a screenshot of your page. You can select what things to take a screenshot of, what things not to. So, for example, well, this is comparing two screenshots. So, for example, in this one, probably the people just tweak the color of the font size or the text, and you see a div from the 2 images. So it's not really nice, but it does the job. Because UA testing is really hard. And I think it's not the solution. It only tells you what did you break, but you cannot know how you break it. So the problem is really what we are doing now. CSS is the problem. You can write CSS as long as the way you want to. So it has bad things to do that. One of the things is global scoping, and I don't know, but my biggest problem is naming things. It's not wherever is a new module to do, I don't know how to name it. It's really hard. And how we do CSS? We use SAS, that is like a helper for CSS. We are going to change it from SAS to SCSS, that is CSS but in an extended way. So you can write CSS, because in SAS the main problem is you have to write SAS, and it's like CoffeeScript or something. You don't do the job. You do another job and then it gets compiled, and you don't know really what you're going to do. So the result. So we are going to change it for SCSS, and I think it's better because lowers the barrier of entrance to writing things. So if you know CSS, you can write CSS. You can keep writing CSS forever, and it's not going to break. And if you want to use SAS, you can use variables, mixins, includes, templating, and functions and everything, and it will work. For all of that, we use Webpack to pack the things and serve it to the audio infrastructure and to the client. So you don't have to serve a lot of CSS files. Because one of the things we do is writing a file for a module, a CSS file for every module. So we can keep things better organized. And of course we use linting And the other thing we do is keep pushing the methodology. We actually use DEM, DEM, that is for block element modifier. It's a thing, this is about naming things. So, for example, if you have a module that is called slider, well, your block name is slider, and then you have a slider, and you use like a slide, and if you want to have another kind of a slide, you just name it whatever you want, and it keeps things organized. The other methodology used in CSS is object-oriented CSS. That is kind of the same thing with another naming, but it's nice. And all of this is because if you don't have a problem, it's the best solution for that. And that's it. You want?
Yeah, so you have any questions, guys, for us?
How much do you care about content performance and accessibility?
A lot, actually, but we have some issues there in terms of performance. Right now, actually, we have a DevOps person taking care of how to speed up things, creating cache, isolating front-end assets into CDNs and things like that. But it's something we have to improve a lot. We are aware that we actually have a very slow website. Yeah, and about accessibility, for example, we try to do very semantic CSS. And yeah, I mean, they can tell you better than me, but we try to focus